Woodworking is all about making strong, clean connections, but getting there can cost a lot of money. You walk into a professional shop and you see these giant machines. There's a horizontal mortiser that costs thousands, a big tenoning table that takes up half the room. These tools are built like tanks, solid cast iron, and they do one thing perfectly. They cut precise joints, day in and day out. For a business, that makes sense. Time is money, and these machines save time. But for the rest of us, the guys and girls in the garage, it's a different story. Dropping 10 grand on a machine you use once a month just isn't realistic. This price barrier can feel like a wall. You see these amazing furniture designs online and you know the key is the joinery. But then you look up the tools and your heart sinks. It makes you feel like you can't play in the same league. You're stuck with a handheld drill and a chisel, trying to get a perfect mortise. You do your best, but it's slow, and it's never quite as clean as you want. You end up compromising on your designs, maybe using screws and pocket holes where a beautiful tenon should be. It's frustrating. It limits your creativity and what you feel you can build. It's a problem I've seen over and over again. So, what's the answer? Do you just give up on ever making those high-end joints? No way. You get smart. You look at what those big machines are actually doing. They're just holding a workpiece and a cutter in a very specific, very stable way. That's it. All that cast iron is just there to control movement and fight vibration. It's a physics problem, and you can solve a physics problem with clever design, not just with money. You can use common materials to build something that does the same job. That's where the idea for this jig came from. It's about taking back control. This isn't about cutting corners, it's about being resourceful. It's about understanding the mechanics behind the cut and building a system that replicates it. We're challenging the idea that you need a dedicated, expensive machine for every single type of joint. We're going to build one single affordable jig that can do the work of a horizontal mortiser, a tenoning machine, and even a dovetail jig. We're going to use a tool most of us already have, a simple handheld router, and turn it into the heart of a precision veneering system. This is how you level the playing field. This is how you build anything you want.
The secret to this whole setup is a multi-axis sliding carriage. It's what gives you the control. Forget expensive linear rails and high-end bearings. We're going to use stuff you can find at any hardware store. The base of the jig is made from 2 layers of 3/4 inch MDF or high-quality plywood. Why 2 layers? For mass and stability. We're fighting vibration, remember? The sliding parts are made from hard maple, which is tough and slides smoothly when waxed. The real clever part is using common plumbing pipes, specifically 3/4 inch black iron pipe as our guide rails. They are incredibly straight, strong and cheap. They become the backbone of the whole system. Assembling the carriage is where you need to pay attention. This is a game of inches, or rather fractions of an inch. The carriage itself consists of 2 parts, a base that slides left and right, the x-axis, and a top platform that slides forward and back, the y-axis. We use blocks of that hard maple, drilled with a Forstner bit to perfectly match the outer diameter of the iron pipes. The fit has to be snug. Too loose, and you'll get slop and play in the system. Too tight, and it won't move. You want a smooth gliding motion with 0 wiggle. I use a little paste wax on the pipes to make everything move like butter. Once the carriage is sliding smoothly, we attach our router. I built a simple, adjustable mount out of plywood that clamps onto the body of my trim router. A trim router is perfect for this. It's lightweight, powerful enough for most joinery, and easy to handle. The mount lets me adjust the router's height precisely. This is our Z-axis, so now we have full 3-axis control over the cutter, just like a CNC machine, but we're doing it all by hand. The whole thing, not counting the router you already own, can be built for under $50. It's about smart material choices, not big brand names. The final piece of the puzzle is the clamping system. On the main platform of the jig, I installed a couple of T-tracks. This lets me use hold-down clamps to lock any workpiece securely in place. When you're routing a deep mortise, the forces are significant. The wood cannot move, not even a tiny bit. Having a robust and flexible clamping setup is non-negotiable. With the stable base, the smooth sliding carriage, and a rock-solid clamping system, we've created a machine that mimics the function of its $5,000 cousins. It's ready to make some chips. Now for the fun part. Let's make some joints. We'll start with a basic mortise. I clamp my workpiece to the jigs platform and lock it down. I set the router bit to the right depth and position the carriage. Then, I just slide the carriage left and right between two stop blocks. The router plunges in and carves out a perfect flat-bottomed mortise. It's clean, it's repeatable, and it takes about 30 seconds. To cut the matching tenon, I just stand the other workpiece on its end, clamp it down, and use the same setup to nibble away the cheek and shoulder cuts. The precision is built in. But this jig does more than just straight cuts. Let's try an angled tenon. All I have to do is shim the workpiece at the desired angle before clamping it down. The router and carriage don't care, they just move in their straight lines. The result is a perfect angled tenon that would be a real headache to cut accurately by hand. We can also cut bridle joints by clamping the wood vertically and passing the router bit through the end. Because the carriage holds the router so steady, the cut is perfectly centered and square every time. The machine makes it easy to get it right. How about something more complex, like sliding dovetails? Easy. I switch to a dovetail bit in the router. I clamp my first piece flat and route a straight dovetailed groove. For the mating piece, I clamp it vertically and adjust the router's position to cut the corresponding dovetailed pin along its edge. The key here is the repeatability of the jig. As long as my setup is locked in, I can make 10 identical parts, and they will all fit perfectly. The same principle applies to finger joints. I use a straight bit and a simple indexing pin to space the cuts, sliding the carriage to make each progressive cut. You see what's happening here? We've turned a simple router into a multi-purpose joinery monster. We're not just making one kind of joint, we're making mortises, tenons, bridle joints, dovetails, and box joints, all on the same $50 setup. The jig isn't the magic, it's an enabler. It enables a basic tool to perform with the precision of something far more expensive. It's about controlling the relationship between the cutter and the wood. Once you have that control, the possibilities are endless. You just change the bit and the position of the wood, and you can cut almost any joint imaginable. So, how does it stack up against the big boys? I took a digital caliper to the joints I made. The mortises were square, with a variance of less than 5/1000ths of an inch from one end to the other. The tenons fit so snugly that they held together with just friction. I made a set of 5-finger joints, and they all slid together with that satisfying zip sound, with no gaps. I even did a stress test on a mortise and tenon joint made with the jig, and it failed where the wood broke, not at the joint itself. The accuracy is there. It rivals what you'd get from a dedicated industrial machine. Of course, the jig has some trade-offs. It doesn't have the sheer mass of a 500-pound cast iron mortiser. This means you have to take shallower passes with the router to avoid chatter, especially in dense hardwoods. You can't hog out a 1-inch deep mortise in a single pass, but that's a small price to pay. The solution is simple. Take 2 or 3 passes instead of 1. The design compensates for less mass with rigidity. The double-layered base and solid pipe rails are specifically chosen to create a stiff frame that resists flexing under load, ensuring the cuts stay true even if they take a little longer. Think about the savings. A good horizontal mortiser is $2,000, easy. A quality tenoning jig for a table saw adds another few hundred. A high-end dovetail jig can be $500. We've replaced all of that with a $50 bill. That's thousands of dollars you can now spend on what really matters. Beautiful wood. You can afford to experiment with walnut, cherry, or maple instead of being stuck with pine. Your project will look better not because of the machine you used, but because of the materials you were able to buy. That's a huge win for any maker. This design is a starting point. You can customize it, make it wider to handle bigger panels, add more clamping options, build a dedicated stand for it. The plans are simple so you can adapt them to your space and your needs. The final image says it all. I put a joint cut on this jig right next to one from a professional cabinet shop. You can't tell the difference. There is no difference. It proves that with a little ingenuity and a good understanding of the physics, you don't need a fortune to make perfect joints. You just need to be a maker.